Good morning, students. In today's class, I will be discussing about process concepts. Students, we know that the two valuable resources of any computer system are one is your processor or the CPU, the other one is the main memory. In our syllabus, there is a separate unit dedicated for process management and one more unit exclusively reserved for memory management. So in order to understand the process management, we need to understand some basic concept related to a process. So in today's class, I will be dealing with the basic concepts of a process. In our previous class, we studied about several computing environments, such as traditional computing environment, where a PC or a computer is directly connected to a network. The two main drawbacks of a traditional computing environment are one is portability is not there and access to remote resource is also not possible. In the client server architecture, some nodes are designated as client which sends a request and one node may be designated as server which receives the request and provides a service. In the case of peer-to-peer architecture, every node is considered as a client and every node is considered as a server also. Whenever a node sends a request, at that time it is treated as a client, and whenever it is providing the service, it is treated as a server. In the case of web-based computing, we have the access to remote resources either through wireless network or through wired network. In today's class, we will be dealing about the basic concepts of process. What are the functions of an operating system whenever it wants to manage the processor? What are the states in which your processor can be? And what is the purpose of a process control block? After attending today's class, you will be in a position to understand, you'll be able to understand the meaning of a process. What is a process? And what do you mean by process management? What are all the responsibility of a operating system with respect to process management? What are the states of a process? And finally, what is the need for process control block? What is the purpose and what information is included in the process control block? A process is nothing but a program which is in execution state. But whenever a process wants to execute mean it requires some resources, because without the resources you cannot execute a process. So a process basically requires CPU time, memory, input output devices. These are some of the resources a process needs for its successful execution. To understand the difference between a process and a program, we will take some example. Assume that you want to do 3 important tasks on a particular day. One is you want to go to a movie, you want to complete your computer science record writing, and you want to pay the fees. So these are the 3 programs you are supposed to do on that particular day. Whenever you are paying the fee, at the time of paying the fee, your task of fee payment will become a process, where the other two, that means going to a movie and writing the practical record of computer science, these two are considered a program. When you are writing a practical record, at that time, that task is considered as a process and the remaining two are considered a program. When you are watching a movie, then at that time, writing a practical record as well as fee payment, these two tasks are considered a program. So that means a process is nothing but a program in execution, so which is in active status, whereas a program is nothing but a passive entity. So whenever during execution, a program is converted into process. When it is not under execution, means it is considered as a program. So every process needs some resources for its successful completion. For example, if you want to go to a movie, so in that case, what are the resources you need? You need money, you need some transportation, and you need some time to watch the movie. So these are the 3 important resources that is required for successful completion of the process called watching a movie. Similarly, your second program, that is writing computer science practical record. What are the resources you need? You need some observation book, then you need a practical record and some time for writing and a pen. So these are the 4 resources required for writing practical record. Similarly, the last program, that is payment as a fee. What are the resources you need? You need to stand in the queue. So you need sufficient time. You need the money. So every process needs some resources for its successful completion. When during execution, when any process, when it is currently under execution by your CPU, it's considered as a process. When it is not under execution by the CPU, it is considered as simply a program. Every process has several tasks. So a process may need 5 tasks. A process may consisting of 10 tasks. Some process may consist of 100 tasks. So in a process, the tasks are executed in a sequential order, one after the other. At any time, only one instruction is executed in a particular process. You cannot execute all the instruction in a process because every process has several instructions. You finish the first instruction, then take up the second instruction. That means your CPU. Your CPU, when you execute the first instruction, then takes the second instruction, execute it, then takes the third instruction, execute it, then go to the last, like that, move from one instruction to another. When it executes all the instruction, we say that your process execution is over. So every process has some basic instruction or the sub-task. So these tasks has to be executed strictly in one particular order, sequential fashion. There is a difference between process and a program. Program is nothing but a passive entity. So a passive entity means it is not at all executed by the CPU or your processor at that particular moment. Whenever it comes under the execution by the processor, it is treated as a process. That means a process is an active entity, whereas a program is a passive entity. Hope you understood the difference between a process and a program. So any program or any process, if it wants to execute successfully by your processor, then we need some resources for that. An operating system has to do the following tasks in connection with process management. Whenever operating system wants to take up the task of process management, then it has to do these subtasks. One is the sum of the responsibilities of an operating system with respect to process management are it creates a user process and it also creates a system process. There are 2 types of process. One is a process created by the user. One is a process that is required for your computer system itself. For example, booting is a process. So that is considered as a system process. Your addition of 2 numbers in a C program, that is considered as a user process. So creation of both user process as well as system process is the responsibility of an operating system with respect to process management. Then deletion of a process. Once a particular process execution is over, then that process is no longer required, means then that process has to be deleted. Then scheduling of process. You have several processes P1, P2, P3, P4, P5, etc. Out of these 5 processes, assume that there is only one processor called one CPU. Then which one has to be executed by the CPU first, whether it is P1 or P2 or P3 or P4 or P5. So in that case, we need to maintain some policies called scheduling policy. So whenever your processor becomes free, then it take up the job which is in waiting state, or which take up the process in one particular order. For example, you have assumed that 3 processes called P1, P2, P3, and you have scheduled. That means suppose P2 is very, very important job, P1 is less important, and P3 is the least important. Then in that case, you schedule the process in the order P2, P1, then followed P3. So whenever your processor is free, means then it first execute P2. After executing P2, it goes to P1. After executing both P2 and P1, it goes to P3. So that arrangement of which process has to be executed first, which process has to be executed next, we call it a scheduling of policy process. So scheduling of process is also another responsibility of your operating system with respect to process management. Sometimes many processes are working parallelly. In that case, some means of coordination has to be maintained among the processes. So that process of bringing out the coordination among the processor is called a synchronization. So an operating system has to synchronize several processors during process management activity. Deadlock. What do you mean by deadlock? Anyway, there is a separate topic called deadlock in your process management that we will explain in the future classes. But to just understand what do you mean by a deadlock, you consider a situation like this. There is a narrow road there is a narrow road. There, the narrow road is possible to pass only one vehicle, either one bus or one lorry. Assume that one lorry is coming from the other side and one bus is going from this side. Then what happens is when they come to the middle point, both will stop. Why? Because the bus driver wants the lorry driver to go back. Similarly, the lorry driver wants the bus driver to go back. So in that case, what happens is both will halt. So that situation, we call it a deadlock. Then at least one has to release the road so that other service will be satisfied. So, but both of them are not ready to use the road for the other one. In that case, both will start, both cannot continue. So that situation, we call it a deadlock. And finally, whenever several processes are working among themselves with some coordination, then there is a need for sending some messages, some requests from one process to another process. So this is a last responsibility of an operating system with respect to process management. One is creation of user process, system process. I give an example also. User process could be addition, subtraction, multiplication of any two numbers in a C program. System process could be booting the system, shut down the system, etc. Deletion of a process, scheduling of process. Scheduling means prioritizing the job. Then synchronization of the process for bringing out the coordination, deadlock handling, and provision of mechanism for establishing communication among the process. These are the 6 different responsibility of an operating system with respect to process management. You consider as a process. What do you mean by process? I already explained. Process is nothing but an active entity which is under execution by the processor. If any process you take during its lifetime, it goes from one state to another state. So each one we call it as a state of a process. When the first time in a process is created, it is said to be a new process. Next, from the new process, so your process is created means you have a new process. Then we need to execute the process. So during execution, the process is said to be in a running state. Whenever the processor is executing your process, at that time we say that your process is in a running state. The processor keep on executing that particular process. At that time, it is in a running state. But in between, suppose that process has some input-output operation to do. So without completing that input-output operation, it cannot continue. But we know that for doing input-output operation, processor is not required. In that case, for doing input-output operation, some input-output devices are necessary. So in that case, what happens is the CPU stop executing that process. Then the process goes to another state called waiting state. Why it goes to waiting state? At that time, because whenever the process wants some IO operation, at that particular moment, your IO device may not be free. So in that case, from the running state, the process moves to a waiting state. It waits till it completes its input-output operation. So whenever the process is waiting for IO device, at that time, we say that the process is in waiting state. After the process completes its IO operation, it cannot directly go to running state, because after completing the IO operation, your processor may not be free. The processor may be busy executing some other process. So in that case, your process, even though it has completed its IO operation, first it goes to a state called ready state. That means I have completed all my IO operation, just I am waiting for your processor. Since the processor is not ready or your processor is not free, the processor, after completing IO operation, it goes to a new state, another state called ready state. Whenever the processor is free, whenever the process is available, from the ready state, it goes to again a running state. Then your processor keep on executing the process. Okay. After some time, again that process has some IO operation. So again it goes to a new state, another state called waiting state, till it gets the IO device. After the process is serviced by the IO device, it comes back to another state called ready state. Then once again go to running state. So running state, waiting state, ready state can be any number of times depending on the size of your process. Whereas after completing its work, after the process is completely executed, it goes to a last state called terminating state. So a process can be in new state only once. A process can be in terminating state only once. But running state, waiting state, ready state. Process can be running state, waiting state, and ready state any number of times depending on the input-output operation. To understand that one, suppose we can compare the process state with our human body also. When the first time when the baby was born, At that time, we say that it's a newborn baby. So at that time, the baby is in a new state. Then after some time, after 2-3 years, the baby started walking. So at that time, we say that the baby is in a running state. Then it keep on growing. In between, the baby fell sick. In that case, it cannot run. So in that case, it has to go to a state called waiting state, because some medicine has to be given to that baby. Once the medicine is given, after 2-3 days, so during that period, 2 to 3 days, the baby is said to be in a waiting state only. Then after it recovers, immediately after the medicine 3 days medicine period is over, baby cannot start walking again, because it needs some rest. So during that time, the baby, even though it's ready to walk, but his or her mother will not allow the baby to walk immediately, because the baby is given some rest. So at that time, the baby is said to be in a ready state. It's ready to run, but still it has to wait. Then after another 2-3 days, once it is completely recovered, again the baby start running. Then after some years, sometime the baby may fell sick again. At that time again it goes to waiting state. Then after it is recovered, it just wait for 1 or 2 days for complete recover. At that time it is said to be in a ready state. Then once again go back. So running state, waiting state, ready state. It could be any number of times during your entire life cycle. So the last state, once the death comes, mean it's said to be, the human body is said to be in a terminating state. So a human being can born only once, can die only once. Whereas the running, falling sick, getting recovery, all these can happen any number of times. This is a diagrammatical illustration of the different state. See, and the first time the process was created, it is said to be in a new state. After the new state, it goes to a state called ready state, because ready state means at that time, because your process may not be free, so just wait for some time till it gets the CPU. From the ready state, it goes to a new state, it goes to another state called running state, keep on executing. In between, if the process has some IO operation, IO request, it goes to waiting state. After completing the IO request, again it goes to ready state, again go to running state, waiting state. So these 3 states can be any number of times. But in some situation, what happens is a particular process is under execution. At that time, we say that the process is in a running state. But in between, another new process request come whose priority is more than the currently running process. Your CPU or your processor is executing a particular process. That process has not requested for any IO operation. But all of a sudden, another program comes and another program requests an operating system where the priority of the new process is more than the priority of the currently running process. In that case, what your processor will do, it will halt your process for some time, pick up the new job, because there's a very, very high priority job, execute that program, then it picks up your job. So that situation where the new request comes, we call it as an interrupt. So during interrupt, what happens is, even though your process is in a running state, immediately whenever interrupt occurs, interrupt means a high priority job comes where it has to be serviced first. In that case, running program has to go to ready state, because it is ready, because it is not requested for any IO operation, but still your CPU will pick up the high priority job. After executing that, then once again it goes to running state. Then after exit, it goes to terminating state. It's a simple example. And the first time when the process is created, it is a new process. From the new process, it goes to a state called ready state, because it just waits for the processor, because processor may not be free at that time. Once the processor is free, the processor start executing your program. At that time, the process is said to be in a running state. Whenever IO operation is required, then in that case, the processor moves from a running state to a waiting state, because the processor has to wait for the IO device, because IO devices also may not be free. So whenever it gets the IO device, it has to get serviced by the IO device. After IO operation is over, immediately from the waiting state, the process cannot come to running state. Once again, it has to go to ready state. Whenever the processor is free, from the ready state, it goes to a running state. So these 3 states can repeat any number of times. But in some situation, what happens is a high priority job may interrupt in between, requesting the processor to service that process. Very, very important, because it's a high priority job. In that case, what happens is your process, which is currently in a running state, should be shifted to another state called ready state. The processor picks up the newly arrived high priority job, service that job first, then it picks up your job, because your job from the running state is already moved to ready state. From the ready state, it pick up your job and execute. Then after any process completely executes, the process goes to a state called terminating state. So these are it's a very, very important concept with respect to operating system, that too in process management. In your examination point of view, definitely there will be a question on process state. Explain briefly the different states of a process with a neat diagram. But you should know when a process moves from one state to another state. When it is first time, when it is admitted, it goes to from new state to ready state. When it is an IO operation, it goes from running state to waiting state. After completion of the IO request, it goes from waiting state to ready state. Whenever an interrupt occurs, it goes from running state to ready state. After complete execution is over, it goes from running state to terminating state. So these are the 5 different states of a particular process. I have illustrated with the example of human life also. What do you mean by a process control block? In the college, to understand the term called process control block, you take the example of a student. In a college, with respect to student, we maintain several information like student name, register number, combination, course, year of study, father's name, mobile number. All this information will be maintained with respect to one particular student. So that is considered as a student record. Similarly, with respect to process, the complete information about the process has to be maintained in one such register. So that register, we call it a process control block. It's nothing but structure. In C language, we call that one as a structure. So a process control block is nothing but a data structure used by the operating system, which contains the information about a process. Complete details about the process is available in the process control block. It's also known as task control block or process descriptor, because this complete description about the process is available in process control block. Next, what information is included in the process control block? First one is process state. So the first piece of information which is stored in the process control block is process state. Already I have discussed about the different states of a process. When you look at the PCB, it tells you the current state of a process, whether it's in a new state, ready state, running state, waiting state, or terminating state. Next, I told you now a particular process has several instructions. Suppose a particular process called P has 5 instructions to execute. That means only after executing all the 5 instructions, we say that process execution is over. Then every instruction we need to store in the memory. Every instruction we need to store it in some location in the memory. We know that every memory location has an address. Then the CPU assumes that the 5 instruction of that particular process is stored in the address 1000, 1001, 1002, 1003, and 1004. We know that which is the first instruction to be executed, the instruction which is stored in the memory address 1000. So at that time, the address 1000 is stored in a special register called program counter. A program counter is a special register which contains the address of the next instruction to be executed. Next, once your processor is executing the first instruction, which is the next instruction to be executed, the next instruction to be executed is in the memory address 1001. At that time, program counter stores the address 1000. After executing the instruction stored in 1001, then program counter holds the address of 1002. So like that, the address of the instruction it next to be executed by the processor is stored in program counter. Every CPU or every computer has a CPU. In addition to your program counter, there are so many other registers available. So you need not bother about these registers, because when we start the process management, I will be explaining these terms. The different registers available in a particular computer are index register, accumulator, general purpose register, stack pointer, etc. The purpose of all these I am going to explain in our future slides. Your process control block also contains the names of the different registers available in your computer system. So one is process state, program counter, and CPU register. Next, memory management information. So again, there is a separate unit dedicated for memory management. At that time, I will be discussing about all these information. So whenever you are working on memory management module, we require some registers like page map table, segment map table, base register, etc. The information about these things are also included in your process control block. Next one is CPU scheduling information. What do you mean by CPU scheduling? CPU scheduling is one technique or an algorithm that decide out if there are several processors waiting for your processor, which is executed first, which is executed next. What is the order in which the different process are executed by the processor is decided by the CPU scheduling policy. So in that case, some information regarding what is the priority of your process, whether it's a high priority process or a low priority process. What is the time quantum? In our time sharing operating system, I explained time quantum is a limit. Every process will get the CPU at least for in one rotation, at least for one time quantum, and which is algorithm you are following for CPU scheduling. All this information also is maintained in your process control block. And accounting information. Accounting information is nothing but, suppose a particular process needs some 100 seconds of CPU time, and out of 100 seconds, suppose CPU was already given for 20 seconds, then what is the remaining time it requires CPU? 80 times. So this information, that is, it includes percentage of CPU utilized, how much time already you have utilized your CPU, what is still, how much time real time it is required, and what is the time still, how much time is pending for successful completion. All this information again is maintained in process control block. So now I think you understood the complete information about your process is stored in your process control block, just like your student register, admission register. One is state of a process. You can understand in your process in which state by looking at your places. Then what is the address stored in your program counter? We can come to know by looking at PCB. And what are all the different registers available in your CPU is available. Next, what are the memory management information? Some memory management information we need to maintain your PCB. Anyway, need not bother about the memory management information because there is separate chapter for that one. I will be discussing at that time. CPU scheduling information that includes what is how many processes are there. Suppose there are 5 processes, P1, P2, P3, P4, 5i. What is the priority of P1? What is the priority of P2? What is the priority of P3, P4, etc. All these are available in process control block. Then, if you are following time sharing operating system, and what is the time quantum, whether it's a 10 second, 20 second, 6 second, etc. And which algorithm you are following, whether you are following first come first serve policy or round robin, etc. Anyway, I will be discussing the different CPU scheduling policies in my next class. And accounting information. What is your process name, P1, P2, etc. How much time that particular process requires, how much time CPU is already utilized by the process, still how much time the process requires to complete its execution. All this information is considered as an accounting information. Even accounting information is also available in your process control block only. This is the structure of a process control block. The first one is process status, process number. Since similar to every student is given a register number, every process is given a number called process number, program counter, register, memory limit, list of some file. So many informations are there. In our previous slide, I have given only some 6 to 7 information about your process control block because they are the valid information or most important information. In addition to that one, some other extra information is also available in your process control block. This is a typical structure of your process control block. Okay, students, in today's class, I discussed about or explained about the basic concept about your process. What is a process? A process is a program under execution. How it is different from a program? Because program is passive entity, because it is currently not under execution, and process is one is currently under execution. What a process requires for execution? A process requires CPU, a process requires memory, a process requires IO device. All these are considered as resources. Then, what are the different states a process can be there? When the first time it is created, new state. From the new state, it just wait for your processor. At that time, it is in ready state. Once it gets a CPU, it goes to running state. Whenever it has an IO operation, it goes to waiting state. Then, after completing IO operation, it again goes to ready state. From the ready state, it goes to running state. During interruption, it directly moves from running state to ready state. After complete execution, the process goes to terminating state. What are the different functions of an operating system with respect to process management? Creation of user process, system process, deletion of a process, synchronization, then establishing communication. All these things comes under process management function. And write up what are the description. What is the purpose of process control? Process control block means nothing but a data structure. Data structure is already studied. It could array, structure, union, all are considered as data structure only. Just like that one, a PCB is also a type of data structure only. It's just similar to your structures in C language. So some important and some very interesting multiple choice questions on today's session is process is dash and program is dash. We know that one is active, one is passive. Process is active and program is passive. The correct answer is B, active, passive. PCB stands for process, control, block. The correct answer is C. Sorry, the correct answer is D, because the C is program control block. When a process completes its IO request, we know that after a process completes its IO request, during the IO request, the process is in waiting state. After completing its IO request, it goes to ready state, because straight away it cannot go to running state because your processor may not be free. It goes to a state called ready state. The answer is B. During interrupt means a high priority jobs arrive. In that case, the currently running process has to be stopped for time being till the high priority job is serviced. So at that time, the process goes from this state. From the running state, it goes to not the waiting state, it goes to ready state. From a new state, the process first goes to ready state, running state, waiting state, either B or C. The correct answer is A, because a new state first moves to a ready state. From the ready state, it goes to running state. Okay, students, hope I have convinced the idea for you. And still, if you have any doubts, you can mail me or you can send your comment in the Google section. And in the live Google class, if you have any doubt, still I will share the same PPT and I will explain again. Thank you.